All right, guys, okay. This is our next type of factoring. It's called sum or difference of cubes. So all those other types, believe it or not, you did those in Algebra 1, 2. This is the first type of factoring. This is gonna be the first time you've seen this one, I think most of you anyway. So let's look at, so it's called sum or difference of cubes. When can we use this? Well, it has to be a binomial. It has to be two perfect cubes. Let's talk about what a perfect cube is. A perfect cube, similar to like a perfect square, except for in a perfect square you'd have the same number multiplied twice. Like the square root of 9 is 3 because 3 times 3 is 9. So 9 is a perfect square. Well, a perfect cube, you need to multiply that number 3 times. So 8 is a perfect cube because 2 times 2 times 2 is 8. 1 is a perfect cube because 1 times 1 times 1 is 1. 1/27 is a perfect cube because 1/3 times 1/3 times 1/3 times 1/3 is 1/27. I want to hear you guys tell me some perfect cubes. I'm going to pause. And we're back. All right, I'm going to erase this here. Now when factoring with the sum and difference of perfect cubes, you've got some formulas that we're going to use. This is the formula. This first one is subtraction, so you know subtraction is different, so this is the formula we'll use for difference of cubes. On the left side of the equation we have the unfactored form, and we have the difference of two perfect cubes. On the right side, this is what it factors to. So the first factor is going to be, the first term is going to be the cubed root of this first term. The second term is going to be the cubed root of this second term. And then the next factor, whatever this first term is, you square it. The second term is going to be the cubed root of this term times the cubed root of this term. And the last term is going to be this term squared. I know it seems confusing, but it's just plugging in stuff, okay? I'm going to try to make it easier. You're going to want to write these formulas down. You're going to want to know them back and forth. You're going to want to study them, okay? Sum of cubes is very similar. It's just, you know how the signs changed here? Well, the signs kind of change here. Notice in this first factor for difference of cubes, we've got a negative. It's negative, plus, plus. And then for sum of cubes, it's plus, negative, plus. I know, it's a little tough, but study over it, remember it. I've heard of some tricks in the past to help you remember it. But this is like the formula, this is like a model, okay? I'm gonna walk you through one. Let's try a cubed minus 8. Now, is this a sum of cubes or is it a difference of cubes? Well, it's subtraction, so it's difference of cubes, right? So we're going to use the top model here. So the first thing I want to do when I do this is I'm going to find the cubed root of a cubed. What's the cubed root of a cubed? A, you're right. So what I like to do when I factor this is, you know how we have this formula up here? Well, I'm going to say what my x is. Okay, I'm going to say my x equals a. And if by saying my x equals a, I can use this part of this formula for difference of cubes. And every time I see an x, I can replace it with a. Okay? And see, I need now to find the cubed root of 8. Now keep in mind, it's not negative 8, it's minus positive 8. So we're looking at this as positive, okay? And what's the cubed root of, excuse me, 8? The cubed root of 8 is 2. So my y, if you will, is 2. So now, by taking the cubed root of the first term, I assign x to a, and now I can replace every x with a. And by taking the cubed root of the second term, I'm calling that my y. And I can replace every y with 2. So now it's just a matter of plugging it in. So this will factor to a cubed minus 8 factors to a minus 2. a squared plus, a squared plus, now we will do x times y, which is a times 2. But people typically don't say a times 2. We typically will put the number first. And it doesn't matter the order in with which you multiply, so it's fine to say 2a. And then lastly, the last term is the y squared. Well, our y is 2. People don't really say 2 squared, do they? They say 4. So that would be it. Factoring a difference of 2 perfect cubes. Now, if you distribute this back, it would multiply to a cubed minus 8, right? It's pretty neat. We're going to try one more. Let's do a nice simple sum of cubes. Let's make it a little harder. Let's go 8x cubed plus 27. So this time we're going to do sum of cubes. We'll start by taking the cubed root of this first term. So this time the cubed root is going to have both a number and a variable. So my x, if you will, my first cube root, my first term, is going to be 2x, because that's the cube root of that. 2 times 2 times 2 is 8, and x times x times x is x cubed. And my y, my 27, my cube root of 27 is 3, because 3 times 3 times 3 is 27. Now look at this sum of cubes formula. All we have to do is replace every x with 2x and every y with 3, and we've got the factored form. So I'm going to have 2x plus 3, and then next I'm going to square this. So 2x squared would be 4. If I squared the whole thing, it would be 2 times 2, which is 4, and x times x, which is x squared. So 4x squared minus, let's see, when I multiply them together, 2x times 3 is 6x, and then plus 3 squared would be 9. Pretty neat. Don't be scared. We're going to practice. Okay, I like it. It's fun. All right. Fun fact. Yeah. Fun fact. This type of factoring takes me back to a very dark period of my life. I might tell you that story one day, but I definitely won't do it on camera. All right. Next type of factoring coming up soon.